November 20th, 1998.
10, 9, 8.
A new era in human spaceflight began with the launch of the first module of the International Space Station.
Main engine start, 6 engines up and running.
After decades of planning and international cooperation, this orbiting laboratory lifted off from Kazakhstan, embarking on a journey that would forever change our understanding of life beyond Earth.
And liftoff. Liftoff of the Proton rocket and the Zarya control module. The International Space Station is underway.
Over the course of the next 2 years, additional modules from the United States, Russia, Japan, and Europe would gradually be assembled in orbit, piece by piece, until the ISS took its final form.
We wanted to build a world-class laboratory in orbit.
A football field-sized research platform circling the globe every 90 minutes.
We are screaming around the Earth at 17,500 miles per hour, and we have to go that fast because otherwise we would just fall down and hit the Earth.
For the past 2 decades, the International Space Station has served as humanity's outpost in the void, conducting groundbreaking experiments, testing technologies for future deep space exploration, and providing a unique vantage point to study our planet.
There's a lot of science that can be done up there that cannot be done on the ground because of the complicating effects of gravity.
But now its time in orbit is coming to an end. As the ISS begins to approach the end of its operational lifespan, plans are already underway to bring it down safely.
We don't want to drop a space station on their heads. So that means you have to deorbit it in a controlled fashion.
Today we're going off the radar with NASA astronaut Stan Love. Stan was part of the team that got the ISS up in orbit and will play a crucial role in bringing it back to Earth. We'll discuss the important work that's been done over the past 25 years on the ISS and why it's time for the mission to end. We'll also look ahead to the next steps in the Artemis program as NASA transitions out of low Earth orbit and into deep space.
The future belongs to the countries that embrace science and technology. That has been true for hundreds of years, and it will only be true in the future.
I'm meteorologist Emily Gracie, and you're listening to Off the Radar, a production of the National Weather Desk. On the show, we dig deep into topics about weather, climate, the ocean, space, and much more. Our goal is to help you better understand the weather and to love it as much as we do.
Why get all your holiday decorations delivered through Instacart? Because maybe you only bought 2 wreaths but have 12 windows. Or maybe your toddler got very eager with the advent calendar. Or maybe the inflatable snowman didn't make it through the snowstorm. Or maybe the twinkle lights aren't twinkling. Whatever the reason, this season, Instacart's here for hosts and their whole holiday haul. Get decorations from the Home Depot, CVS, and more through Instacart and enjoy free delivery on your first 3 orders. Service fees and terms apply.
Hey, Prime members! Have you heard? You can listen to your favorite podcasts ad-free? Good news! With Amazon Music, you have access to the largest catalog of ad-free top podcasts included with your Prime membership. To start listening, download the Amazon Music app for free or go to amazon.com/ad-free-podcast. That's amazon.com/ad-free-podcast to catch up on the latest episodes without the ads.
Okay, so you are a NASA astronaut. You have been for decades, so I can't wait to dig in and talk to you a little bit about your history and the future of what's going on with space travel. Can you take me back to the beginning of kind of how you became an astronaut? And I was looking at your history, and I'm doing the math right. You were alive for the first walk on the moon, correct? But you were probably
I was 4.
Very young. Do you have any memory of it?
I do actually, not the first moonwalk, but one of my earliest memories is from first grade when I was 6. Watching, I think it was the Apollo 16 splashdown. They wheeled in the big black and white TV on the tall cart so we could all watch it. And that was pretty cool. And then 30 years later, the commander of that mission was interviewing me for the position of astronaut. So John Young was on that flight, and he was the chief of the selection board on at least one of my interview years.
Wow, surreal. Okay, so was that the inspiration? Did you always have this goal of becoming an astronaut, or is it something that you just kind of wound up in?
Neither. I loved science fiction as a kid. I grew up on the original Star Trek. I ate up science fiction novels, and it always just seemed like something fun. And so in school, I studied physics and astronomy because I thought space was cool. And then had a little bit of aeronautics, a little bit of aeronautical engineering. And as long as what I was doing was consistent with what they were looking for astronauts, I sent in an application and did that for 7 years and interviewed 3 times. And finally, I think the selection board got tired of me. So I figured the best way to get rid of me from the selection standpoint would be to hire me.
Okay, so you became an astronaut in what year?
1998.
Big time for space travel. So that was kind of the time of the space shuttles, right?
Yeah, there's a space shuttle. And that year, we launched the first part of the space station.
Which is what today's episode is all about, is the lifeline of the International Space Station. So it's funny because I guess I'm young enough that I didn't really realize that it wasn't always there.
Nope.
I was a grown-up before I realized this thing came up when I was in high school.
And my classmates and I built that thing.
It's amazing. Was this the first time there was a space station?
No, for heaven's sake. The Russians have had space stations for many decades. All through the 70s, they were flying Salyuts and then Mir. And in the 70s, the United States had Skylab for a little over a year, I think. So there have been many space stations, but nothing nearly as big and as complicated as the International Space Station.
Okay, so I'm guessing it went up in pieces?
Absolutely. It weighs 450 tons or something like that. And even Elon can't launch that in one piece.
How many times have you used that line?
This is the first.
Oh, yes. Okay, so what was the goal here when this project started? What was the hope for the International Space Station?
Well, we wanted to build a sort of world-class laboratory in orbit. There's a lot of science that can be done up there that cannot be done on the ground because of the complicating effects of gravity. And we also wanted to spend lots of time with lots of people in space to learn everything we need to know so that we can go deeper into space, back to the moon and then on to Mars and beyond. And so we needed a stable, capable laboratory in low Earth orbit. And that's what the International Space Station is. And then, of course, from a bigger picture, having most of the spacefaring nations on Earth working together in space is also very helpful.
Helpful, but also that has to be complicated. I mean, just the dynamics of all these different countries coming together and getting anything done, let alone getting different pieces of equipment up in space. So what was that process like? How did you decide who's in charge of what? The cutest one, I think, is Canada with they just have the arm, right?
They do, but let's not call them cute. All the partners contribute as they are able.
Okay.
Of course, each country has a control center for their parts of the space station. And those control centers are in communication with one another all the time. And we talk as we need to, and we solve problems together, and we generally make it work.
How many languages do you speak?
I speak English, Russian, and German.
I'm guessing that's probably pretty important when it comes to doing this.
You have to be able to speak some Russian to fly on the space station. I already spoke German. I lived in Germany for a year. My family lived in Germany when I was a kid, and I still remember much of my German. Backing
up to when you first started going to space and you were training to be an astronaut, there's got to be like a physical aspect to this, right? Where you have the PhD, you have the knowledge, but then training physically to be an astronaut. What is that like? Not really well scoped or written down or anything like that. There's a medical exam you have to pass each year. But there's this widespread public perception that astronauts are all perfect physical specimens and decathletes and everything, I think it's because we always see them like jogging on treadmills in the ISS. Yeah. And when you go to space station, it behooves you to exercise like a crazy person because otherwise your body, muscles, bones are going to waste away. And when you come back to Earth, you'll be a jellyfish. And we don't want that. So yes, they're always on the treadmill. But, Sonny Williams famously ran the Boston Marathon on the ISS, ran 26 miles on the treadmill on the day of the marathon. But cool. not everybody does that. Yeah. Frankly, there are maybe a couple of astronauts who we should see in the gym a little more often. Okay, so what's it like going to space? The first time you went up, broke through the atmosphere, what was that experience?
Well, the launch is very impressive. There's a lot of roaring and shaking, and your seat pushes you pretty hard in the back, and you realize you're definitely going somewhere in a great big hurry. That's about an 8-minute ride on the rocket to orbit, depending on which rocket you ride to orbit. And then when you get there and the engines shut off and you're floating in your straps, your first thought is, wow, I'm floating in space. And your second thought is, I have to get to work right now, because we had a lot to do and only barely enough time to do it all in.
Were you sick?
I wasn't sick. I like to say I did not get sick in space because I had the right stuff. 25 milligrams of Phenergan.
What is that? It's like an anti-nausea?
It's an anti-nausea medication. So yeah, you can take medication against space sickness. About a third of people, when they get to space, feel bad enough that they throw up. About another third get sort of stomach awareness. Like if you're reading in the car and someone else is driving and your stomach, you feel a little queasy and you kind of don't want to move your head around a lot. And then the other third are probably not telling the truth.
I just got your reference there, The Right Stuff. That's not, I didn't see the movie.
You should see it. It's a funny movie.
Is it? Okay.
Yeah.
We're going to go back to movies in just a minute. But I want to talk about your role too in getting stuff up there. So how does that work? Was the mission that you were on, was that part of taking some of those things up to put the International Space Station together? Yes.
We were one of the space station assembly flights. So the space shuttle looks like delta winged airplane, and most of the body of that airplane is a big cargo bay that you can put big stuff in. So we had a canister shaped laboratory about the size of an RV. That was the European Space Agency's Columbus laboratory. It was their big hardware contribution to the space station. So we had that in our payload bay. We took it up to the station. We docked with the station, then used the station's robot arm to pick that module up out of the payload bay, swing it around, put it over a docking port where a ring of powered bolts drove to attach it to the space station. And then we could open up the hatches and have a new laboratory on the space station.
Were you there when the hatches opened?
No, I was busy with other things. I was a spacewalker and main shuttle robotic arm operator. So I wasn't there when the hatches opened. Interestingly, you have to wear goggles when you open up a new module because all the little aluminum chips left over from manufacturing it, even though they try to keep it clean, once that stuff gets up into space, it starts floating around the cabin. And you don't want to inhale that or get it in your eye. So until we've run the ventilators and with the screens on the ventilation inlets for a day or so, you have to wear goggles when you're in a new module. Okay, so if you're spacewalking, can you tell me what that experience is like? It's really unnatural. You're crawling around on the outside of this gigantic metal object with handrails that you can climb on. You're very sensitive about making sure your safety tether is where it ought to be. You have a power tool. Everything in the suit is very hard to operate. It's pressurized, which means that just closing your hand around a tool or around a handrail is like trying to squeeze a tennis ball. So it can be physically very challenging, even though there's no gravity. And then most of the time you've got a station wall right in front of your face, and only occasionally do you get to look off to the side and go, wow, here I am. There's the Earth. And what's that like? What's it like looking at the Earth from that vantage point? Oh, it's awesome. Any time an astronaut has a spare moment, they're looking out the windows and at the Earth. The Earth is, speaking as an astronomer, the Earth is the most interesting thing in space. Okay, so how long were you up there? 2 weeks. And what's life like up there? It's a lot of work. You pause briefly for a meal now and then. You try to get some sleep at night. It's an unfamiliar environment, and there's a lot of risk, so not everybody sleeps super well, and then you get up in the morning and go back to work. Did you have trouble sleeping? Yeah, and most people do. Yeah. But it's for the long duration crew members who are on space station for 6 months. They can kind of get used to it, and I think they sleep pretty well at night, but it was very common for shuttle crew members to not sleep super well. Okay. You mentioned science that you can't do on Earth because of gravity. Can you give me some examples? Fluid flow is really different in space. Flames are incredibly different in space. We have a little combustion lab, very well isolated from the cabin, where we can light things on fire and see how flames work when there's no buoyant force taking hot gas away from the flame. Then, of course, we can observe the Earth in many ways. There are Earth observing instruments. There are space observing instruments. There's a giant cosmic ray detector on the space station looking for antimatter and other stuff coming in from distant space. I think at any given time, there are probably 200 to 300 different investigations going on the space station. And then much of the science has to do with the people themselves. We study how our bones and muscles change, how our eyes change, how our sense of balance changes when we are not under the influence of gravity. And all these things are important for us to get a handle on before we send people off to Mars, which would be about a 3-year trip.
So has anything come out of this that's been really surprising, or anything that NASA's been like, oh, I'm so glad we know that now before we did do this?
Well, I mentioned eyes. It turns out that in space, most people's cerebrospinal fluid, so this is the watery fluid that bathes your brain and spinal cord, the pressure in that goes way up, which is very unusual on Earth. And it can actually get so bad that the pressure in your eyeball also goes up, and it can actually damage your eyesight. And you'd hate to land on Mars and not be able to read your checklist.
Oof.
So we have a lot of investigations going on trying to understand why that happens. It's not known. And then what can be done about it.
Interesting. So have people who have been on the ISS for months, have they had vision problems?
Some of them have come back with changed vision, yes. And of course, everybody's muscles and bones get weak up there. Although the weightlifting equipment we have up there is pretty good. And so at first we had people showing a lot of muscle and bone loss, but these days our crews are coming back pretty healthy. In fact, crew 8 just landed last week. I saw 2 of them in the gym today and they look great.
When you did come back and land, was it hard to adjust to gravity?
Yeah, it is as disorienting coming back to gravity as it was getting used to zero gravity. And it kind of makes your head spin the first day. It's kind of like I'm told it would be like if you had 6 beers. I have no personal experience with this, of course, myself. That's landing day. And then the day after landing, it's like 3 beers. And the day after that, it's like 1 beer. And then after that, they let you drive your car.
So speaking of having fun, I'm guessing that emotionally, mentally, especially for people who are up there longer, it can be a tough place to live. So I'm curious,
it is
mentally how that works.
The shower is unsatisfactory. The toilet is unsatisfactory. The food's okay, and you get to choose your favorite food, but you still get tired of it. But then you can trade with your crewmates.
What's your favorite food?
My favorite space food was creamed spinach. I wouldn't touch it with a 10-foot pole on Earth, but for some reason in space, it tastes really good. Your sense of taste does change when you get up into zero G, partly because actually things taste really bland. There's a system in your body that's always pumping fluid up from your legs up to your upper body, keeps your ankles from swelling most of the time. And then when you get to space, that system keeps working. So it pumps all the fluid up into your upper body, and your head kind of gets stuffy like you got a bad cold, and you can't taste your food very well.
Oh.
So they had to add a lot of salt to the food, and then they figured out that's too much salt. So then they took the salt out and added real spices. And then if you ever see a photograph of astronauts eating around the table on the space station, you will see several different types of hot sauce. It is all about the hot sauce. They put it on everything.
Adding flavor. That makes sense.
Yeah.
Has there been incidents of people kind of like losing it mentally when they've been up there for long periods of time?
Yeah, no. Very popular in the movies. No. We select our astronauts carefully. And if you look like the kind of person who's going to lose it when things get tough, you don't get hired.
Oh, makes sense.
And we train them carefully. And among other things, we train them so that if they are having a bad day, they know they can talk to their crewmates, they can talk to their flight surgeon on the radio, they can have a video conference with their family. So we put a lot of thought into that, but that thought begins with selecting people who are even-keeled, self-aware, and have the tools to not lose it.
Okay, so we were talking about being up in space and experiments and science that's going on up there, which, we are a weather show. So I'm curious, are there any type of weather science experiments going on?
Yeah, I think the station has a scatterometer on it that bounces radar off the ocean surface from which we get wind speed. And then every time there's a volcanic eruption or a hurricane, the crew's busy with their cameras taking pictures of it.
Heck yeah, we love those pictures.
Yeah. I think there was a volcanic eruption in Kamchatka 15 years or so ago, and it was cloudy, and there's not that many observers in Kamchatka. And I think the first pictures of that came from the International Space Station. They flew right over it just as the plume was bursting through the cloud layer, and you could see this big brown lump growing up out of the white clouds.
Wow, interesting. Okay, so throughout the day on the ISS, what are the different roles that people have? Is there like housekeeping stuff along with the experiments that are going on? What is going on?
So the systems on the station, the power supply, the air fans, the pumps, the data system that's controlling the station, that's largely run by mission control remotely.
Oh.
So the things we have the crew doing are the things that only the crew can do because they have hands and eyes up there. So their first order of business is they have to keep themselves healthy. So they're exercising 2.5 hours every day. They get a break at the beginning of the day and to the end of the day to have decent meals. There's often not time for lunch. You have to kind of grab a granola bar or something on the go for lunch. And then there's some medical data takes on them to make sure that we can monitor their health and make sure that they're staying healthy. So job number 1, stay healthy. Job number 2, make sure the station's healthy. When something breaks, and we have to, change a pump or change a hose or something like that, and only the crew can do that. That's what they do. And then after that, almost all of their available work time left in the day is doing these science experiments. Now, they don't normally design the experiment, but they, push the start button or they change out the sample canister and things like that. Then there are special events. If there's a spacewalk, they'll spend a couple of weeks getting everything ready for the spacewalk, learning what they have to do, getting the suits ready, getting the tools ready, then going out the hatch, doing the job, and then coming back in and cleaning up. When a cargo ship comes up, they have to unload all the cargo, find places to put it, and then they usually reload it, depending on which type of cargo ship. If it's going to be one of the ones that burns up in the atmosphere at the end of its mission, they load it up with trash. And then that undocks and goes and burns up in the atmosphere. Or if it's a return cargo ship, then they'll send, scientific samples, worn out equipment, things that have to go back to the Earth for some reason or other, go back on those ships.
Can you explain, because something I used to not understand was I thought the ISS was just like floating out in space, but the reason for the lack of gravity on the International Space Station and just how close it actually is to Earth?
Yeah. So if the Earth is this big, the station is about that high above it. So it is just above the top of the atmosphere. The Earth is a ball about 8,000 miles in diameter, and the station is about 250 miles up. And if you built a tower 250 miles tall and stood on the top of it, you'd need to be in a spacesuit because there's no air up there, and you would perish immediately if you didn't have a suit on. You would feel something like 94% of your normal body weight. There's oodles of gravity where the space station is, but the station doesn't feel it because it is in free fall. It is falling toward the center of the Earth just as fast as it can, but it doesn't hit the atmosphere or the ground because it's going forward so fast that by the time it has fallen down to where the ground is, the curvature of the Earth has made the ground go away from it. So it's always trying to fall down, but it's over the horizon before it can hit. And it just keeps falling around the Earth. That's what it really means to be in orbit. So we're not very high up, and we're not just floating around in empty space. We are screaming around the Earth at 17,500 miles per hour, and we have to go that fast because otherwise we would just fall down and hit the Earth. But this way we're going so fast that the curvature of our path going down to hit the Earth matches the curvature of the Earth itself, and we never hit.
That's a crazy concept to grasp, I think, unless you're knowledgeable on the topic.
I have found no better way to explain it to somebody who doesn't understand it. You're going so fast that you're over the horizon before you hit the ground. That seems to resonate with most people.
You told me why it was going up, but can you tell me why the life of the ISS is now coming to an end?
For the same reason the life of anything comes to an end. It gets old and worn out. The structure has a finite lifetime. Any piece of metal, you take a paper clip and you bend it back and forth and it'll break. That is true of anything made out of metal, including an International Space Station. And the space station is always getting bent and flexed and stuff like that. Partly from gravity gradient docking vehicles. The crew members exercising is actually a big deal for space station lifetime.
How does that work?
Interestingly enough, have you ever seen the video of the Tacoma Narrows Bridge?
Oh, yeah.
Galloping Gertie? Okay. So that happened because the bridge, unbeknownst to its builders, had a resonant frequency that happened to be exactly the same as a subsonic note in the wind blowing through that channel. And it excited that fundamental mode and the bridge fell apart. It turns out that the fundamental mode for the space station's great big truss with the solar arrays on it is exactly the same as the frequency of a crew member pounding on the treadmill as they're running.
So how did you find this out?
Oh, we found it out when we put it up there and put a crew on it and said, uh-oh, look at that. So, next time we'll know better. But anyway, and there are actually parts of the station's pressure hull that are already showing cracks. There's a lot of concern right now for some cracks on a part of the Russian segment. And we don't even want to have the hatches open when they've got that section connected to the rest of the station because it's fairly serious. So anything, any machine, any creature, a star, a planet has a finite lifetime, and we cannot build things that last forever. So, and plus, the pumps get old, the computers get old, glitches start appearing, and eventually it is going to be too expensive to maintain for what we get out of it, and its capabilities are going to start to decrease, and it will become unsafe for people to live there, and we do not want to put people on a machine that's so old that it's not safe.
Can you tell me what it coming down looks like and what the timeline on that is?
Okay, so 2031, I think, is when we are planning to deorbit the station now. Now, it costs a lot of money, and it is still more or less working, so we might extend past that, but there are international agreements that go with that. We also want to start building a new space station in orbit around the moon, and if we're spending all our money on the old one, then we can't afford the new one. So there's lots of discussions that happen way, way above my pay grade. They're going to happen to determine when the space station actually comes down. Now, the problem is it weighs 400 tons. Back in the 70s, we had Skylab, and 15 or so years after we were done with it, its orbit decayed and it re-entered the atmosphere, and bits of it fell on Australia, and Australia was understandably not super excited about that. The space station is much larger. A lot of its pieces might survive atmospheric reentry, and when an object in orbit has its orbit start to decay, it is literally not possible to determine where exactly it's going to come down. It descends into the atmosphere gets a little thicker, that puts drag force on it, that makes it descend quicker and so forth, and that happens over the course of many orbits and then finally over just one orbit, and there is no way to predict that. And it means basically anywhere on Earth between the northernmost and southernmost extents of the space station's orbit, which is at 51 degrees latitude, which includes like 90% of the population of the Earth, could be a target. So we don't want to drop a space station on their heads. So that means you have to deorbit it in a controlled fashion. And that means you have to be able to slow it down so that it enters the atmosphere decisively instead of just kind of gradually skimming in. You need it to come down at a good angle. And for a station that weighs 400 tons, that means you need a fairly powerful rocket to slow it down quickly over the course of minutes so that it will dip down into the atmosphere steeply, and atmospheric drag will cause it to heat up. Eventually, it will fall apart. All the individual elements will enter separately, and we want to put them in the South Pacific Ocean where nobody lives. And there's precedent for that. When the Russians brought the Mir station down, there's great video of from Tonga showing these giant fireballs coming across their sky. Now, nothing landed on Tonga because everything went way downrange before it actually hit the ocean. But that's where we want to put it. And we have, I think, just let the contract to build the rocket that will go up, dock with the space station with still a full load of propellant on board so that it can then fire that rocket and bring the station down in a controlled fashion so we can drop it, over the Pacific Ocean, Central Pacific, 50 degrees south latitude. That's actually near the point in the ocean that is furthest from any land, and not much shipping goes through there. So it's the safest place on Earth to bring the space station down. And then if any of your subscribers are H.P. Lovecraft fans, it's also the location of the sunken city of Rolaya. So we give all our garbage and our dead stations to Cthulhu.
Wow. Okay. So this is all coming down at once. I guess I thought it was just going to be like piece by piece by piece, but
the station was hard to put together. Taking it apart would be just as hard. All those modules are connected not just by a powered bolt interface, but most of them have lots and lots of cables and hoses connecting them together. And you would have to disconnect. It would be hundreds of spacewalks and, dozens of flights to the station. If we started that work now, we would not be done in 2030.
So when it comes down, is it going to be a slow descent like with the balloon?
No. It's going to hit the atmosphere at 8 kilometers per second, just like everything that comes back from low Earth orbit, and it will break up and the sections will burn up largely. And everything made out of steel or titanium will probably hit the ground. Aluminum, glass, plastic, all gets burned up.
So what does that look like when it hits the ocean? Is there like a giant wave, or is it in so many pieces? No.
All the cosmic energy, all the speed energy gets used in coming through the atmosphere. So it'll look like a giant meteor fireball when it comes through. And then when it breaks up, it will look like a bunch of giant meteor fireballs. All of its orbital speed will be gone. And when the small roughed over pieces hit the ocean, they will hit at the same speed that they would if they were just dropped from an airplane.
Okay. And then do they get scooped up? Is there an effort to gather these up, or are they nope?
Nope. Burned up titanium doesn't have a lot of value, and trying to scrape the stuff off the ocean floor would be very expensive.
Okay. And environmental impacts?
Steel and titanium, not so bad. And the stuff that burns up high in the atmosphere and in a plasma environment that basically separates all of the atoms from one another. Everything ends up basically back in its fundamental elements. Heavier atoms will settle down through the atmosphere over a wide area. It's I would expect no environmental impacts from that whatsoever.
This is kind of wild. Surely NASA's going to keep some pieces for some museum somewhere?
Only pieces that we bring down from the station before we deorbit it. But anything on board the station when it goes into the atmosphere is forfeit. We're not getting any of that stuff back.
All right. Okay. So the next steps. Let's talk about what's next for NASA. After ISS comes down, you mentioned perhaps a space station around the moon. What does that look like? Is it similar to what we've had here orbiting around Earth?
It's going to look like a very small space station. So it'll have solar arrays and some cylindrical habitable modules, and vehicles will dock to it. And it's like a mini space station, but emphasis on the mini.
Okay. And what's the point of it?
It is a transit hub that allows us to take landers and crew vehicles and switch cargo and switch propellant around in orbit around the moon. So it's like the transit hub that allows us to access the surface of the moon.
You're heavily involved in Artemis, correct? Can you tell me what your role is and what next steps are? Because some of this stuff that sounds very futuristic is not that far in the future, right?
I've been pretty much up to my eyebrows in Artemis for the last 20 years. I've been working on the Orion vehicle since it was a winged space plane in 2004. Now it's a capsule, and it's flown a good test flight. I was there at the creation of the SLS heavy lift rocket that takes Orion into space, and was the astronaut office representative on the design team for that for many years. I was the lead Capcom for Artemis 1, which was super easy. We didn't have a crew on board, so I didn't have any calls to make. Got through the whole mission without making a single bad call. I'm also lead for Artemis 2, and there will be bad calls because I'm actually going to be making calls. And then separately, for the last 7 years, I've been working in the astronaut office's rapid prototyping laboratory. We design and test cockpit displays and controls for future spacecraft. And we built the Orion user interface to the extent where we designed everything and then handed it over to Lockheed, and they put it together the way we said. And that's what's flying. I am in charge of the Gateway Stations user interface, which is going to be on a laptop computer much like the current space station uses a laptop computer for the crew to control it. I am also working on displays and controls for future spacesuits, rovers, lunar habitats, and that sort of thing. I have been involved in a bunch of Mars exploration studies, asteroid exploration studies. I used to study asteroids for a living. So when they talk about sending people to asteroids, it's like, let's talk. The environment is going to be very weird on an asteroid.
I could probably ask you questions for days, but because you mentioned the asteroid thing, I want to dive in a little bit to space in the movies. And I'm curious.
Oh, Lord. Okay.
I'm curious what your thoughts are on Armageddon. Like, what was, when that came out, what were you horrified? Were you like, ooh, this is fun?
No. I expect ignorance to be on display. One of my favorites was Independence Day. The first technical error occurred in the first frame of that film.
Okay, what was that?
They show one of the Apollo lunar plaques on the moon, and the giant alien spacecraft is flying by, and the vibrations from the spacecraft are shaking the dirt around that. Yeah, no. Even if your starship vibrates, which it shouldn't, that's wasted energy. There's no way to transmit that vibration through the vacuum of space to the surface of the moon when your ship is going by. So Armageddon. I watched it with my wife when the Brave crew is landing on the asteroid. And there was this weird blue-green vaporous stuff coming off of the asteroid. My wife leans over and says, "What's that stuff?" And I said, "Art," because there's nothing like that on a real asteroid. It's going to look like a pile of avalanche debris, stones all jumbled together, held together by its own self-gravity. Even most asteroids aren't even a solid rock. They're just impact debris that's kind of barely stuck together by its own self-gravity.
Is the premise crazy, or is that far-fetched of redirecting?
Will we split it in half and have one half go on one side of the Earth and the other half on the other? No. Will the asteroid be as big as Texas? No. There is exactly one asteroid in the solar system the size of Texas, and we know exactly where it is. And it's not coming here. So no, they get almost everything wrong. I come out of space movies with a big red mark on my forehead from slapping myself. There are a couple of exceptions.
Yeah, I was going to say.
The Martian gets a B.
Yes. Andy Weir is not terrible, right?
The vast majority of his science is really good.
Did you read Hail Mary?
I did. It's cute.
Okay.
It is science-based, but it's still pretty fanciful in my opinion.
Did you watch, I did not watch it, but ISS, where like war is breaking out?
Got no inclination to go there.
Yeah, no, it looks awful.
But I can tell you though that, despite the tense political situation on Earth, we have international astronauts and cosmonauts on the space station, and they still get along like this.
I figured.
They all wish their governments would get along better, but once you put people in space and away from the Earth, they, to a large extent, represent the Earth and a little less just their own home country.
What is the wildest thing you've seen from space, either on Earth or anywhere?
Let's see. We had some interesting things to look at on my shuttle mission. One thing that really raised my eyebrows, we flew in February, so it was winter in the Northern Hemisphere, and our orbit took us over Siberia during the day several times each mission day. And over the empty steppes of Siberia, there were these parallel lines that looked like the character Wolverine had taken his claws and gone across hundreds of miles of Siberia, these long, parallel, jagged lines in black against the white, snowy steppes. And I'm like, what on earth is that? And it turns out during Soviet times, they were trying to farm Siberia. And one of the things that they did to try to make this happen was they planted rows of trees to make windbreaks to slow the wind down so it wouldn't like blow the topsoil and the baby plants away. And so they planted these parallel rows of trees, and you can see this from space, and it's just eye-opening. Another interesting thing was in the middle of the Sahara Desert, there's a big area of old volcanoes called Tibesti. It stands out as black rock against the tawny desert. And there's mountains there. And in the top of one mountain, there was this brilliant white spot. And I was wondering, is it high enough for snow? It turns out it's not. It's a mountain called Amikusi. Probably have butchered that pronunciation. But it's an old volcanic caldera. And during the Ice Age, when it was wetter, it had a salt lake in the crater in the top of that mountain. And now it's just a dry salt pan. But I guess the Bedouin used to go up there to get salt. So you can see that from orbit. Those are two of the highlights that I saw on the Earth from my mission.
Wow. Stan, are you ever going back to space?
I don't know. I don't make that decision. I'm eligible.
And when are we sending our first woman to the moon?
We're sending our first woman around the moon next year on Artemis 2. Christina Cook is going to be on that crew. Then the first landing, I think we're on the schedule for 2026, but don't buy your tickets to Florida for the launch just yet.
And when does the crew get announced for that?
For Artemis 3?
Yeah.
Not before Artemis 2.
Okay. This is very exciting. Dr. Stan Love, I don't have anything else for you. Do you have anything else you want to share about the future, the work you're doing at NASA, or the ISS in general?
Well, the future, the work I do at NASA and the ISS in general is all totally cool. If you're interested in science and technology, come work for us at NASA. We love creative, technical people. There's a lot of folks who are kind of jaded about the state of Earth and everything, but we are creating an amazing future, and I welcome anybody who's interested to come and help us do it.
Yeah, and I want to ask you real quick before you go, a hard question, because there are a lot of people that think, why are we spending so much money on going to the moon or going to Mars? This is very expensive. Can you tell me why?
NASA consumes 0.5% of the federal budget. If you did away with NASA, okay, no more Mars probes, no more astronauts, no more space station, no more Jupiter probe, no more beautiful pictures of Saturn, no more understanding where our solar system came from, where our universe came from. All that goes away. And you increased the budget of every other federal agency by 0.5%. You would have lost our world and our future and basically gotten nothing in return. All of that money that NASA spends, it spends on the ground, vast majority in the United States itself, supporting jobs and communities all over the country. We get amazing new technology. We get inspiration for kids to get interested in science and technology. And the future belongs to the countries that embrace science and technology. That has been true for hundreds of years, and it will only be true in the future. And if there's nothing interesting to make kids excited about science and technology, they won't be. And, we'll be farming and the Chinese will be on Mars. So that's not a future I want.
Well, Dr. Stan Love, it was so nice to meet you.
Okay, likewise.
Off the Radar is a production of the National Weather Desk. Make sure you're following the show on Apple Podcasts, Spotify, or wherever you listen to podcasts. New episodes published every Tuesday morning. If you liked today's show, please share it with a friend and make sure you check out some of our past episodes. We have plenty of them that are all about space. Thank you to Dr. Stan Love and the team at NASA for joining me today and providing the sound at the beginning of the episode. Also, thanks to my associate producer, Brian Petrus, for his help on this episode. For the National Weather Desk, I'm meteorologist Emily Greasy. Make it a great day.